press the bell icon on the YouTube app and never miss another update.
Hello students, today I am going to continue with the exercise 2.3. So in the previous class I had shown you the first main of the exercise 2.3. Now let us start working the second main of the same exercise, that is 2.3. Now I will read the question. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. I repeat, check whether the first polynomial, here I have written the question for you, the first one. You have to check whether the first polynomial is the factor of the second polynomial by dividing the second polynomial by the first. I hope it is it's clear. See here. Now if suppose, see in the lower classes you have learnt what are factors. See for example, if I take the factors of 15, if I ask you to write the factors of 15, what you will write? 1, then 3, 5 and 15. Now these are the factors. Why we call all these are the factors of 15? See for example, if I take 3 and I will divide 5, 3 5s are 15. So the remainder will be 0. Means 3, if you divide 15 by 3 or by 1 or 5 or 15, it completely divides 15. Means the remainder will be 0. Suppose if I ask 4 is a factor of 15, we say no. Why? Because we cannot divide 15 by 4. 4 3s are 12. 3 is the remainder. Now, so to be a factor means it should divide completely, means the remainder should be 0. So the same thing you apply here now. Now you are dividing this polynomial by the first one. So when you divide, if suppose the remainder is 0, that is r of x, I told you in the previous class, r of x if it is 0, then we call this is a factor of the second polynomial. The first polynomial is the factor of the second polynomial. Suppose if the remainder, if you get other than the 0, if there is a remainder, then we can say that the first polynomial is not the factor of the second one. Yes, this is simple division which already I showed you in the previous examples problem. So once again we will try to do this. Now 2t to the power of 4 plus 3t cube minus 2t square minus 9t minus 12. Let us divide it by t square minus 3. And in the previous class I told you, see here, how to divide this. So the first term you take t to the power of 4 divided by the first term t square. So you will get, what is the answer? T square gets cancelled. So 2t square. So the first term will be 2t square. I hope it is clear. So then multiply. See, you have to multiply like this, t square minus 3 into 2t square. You have to do like this. But I am going to do it here only in the problem. So 2t square into t square. So you will get 2t to the power of 4. Then minus 3 into 2t square. So 3 2s are 6t square minus 6t square. So you should observe carefully, here it is, the degree is 3 here. The exponent of t is 3 here. So you can't write here below this. So you have to write here, that is plus into minus, minus 3 2s are 6t square. Now what is the next step? You have to change the sign. change the sign. Now, here it gets cancelled. 3t cube you write like this as it is, you have to take it down. Then minus 2t square plus 6t square. So, the greater number sign, that is plus. So, here 6 minus 2 it is 4t square. Then you take 9t down. Now, again you divide this 3t square cube, 3t cube by t square. So, what remains? 3t. So, the next term will be 3t plus, here when there is plus sign you have to take plus. So, 3t. Now, see here 3t cube multiply t square into 3t cube plus into minus 3 3s are 9t. So, here 4t square, under this you can't write anything. So, here you write minus 3 3s are 9t. Now, again change the sign, minus and here plus, and here you can cancel, here also minus t and plus t gets cancelled. What remains here? 4t square, then one more term is there here, minus 12. Next term 4t square by t square, so 4. So, divide 4t square by t square. So, what is there? 4 remains. So, that 4 you should write here plus 4, that is the third term. Now, 4 into t square, 4t square plus into minus 4 3s are 12. Now, again change the sign, this will become minus, this will become plus. So, it gets cancelled, this also get cancelled, the remainder is 0. Now, we can come to the conclusion that the first polynomial is the factor of the second polynomial. So, you should write, you can't leave like this without writing the conclusion. You should write, therefore, I will write here, therefore, t square minus 3 is the factor of, yes, you have to write this, 2t to the power of 4 plus 3t cube minus 2t square minus 9t minus 12. Like this you have to write. Or you can take this as g of x and this as p of x. Then you can write g of x is the factor of p of x also, if you don't want to write like this. But the conclusion is very, very important, because the question is only you have to check whether the first polynomial is the factor of the second polynomial. So, the main intention of this question is to ask whether it is a factor or not. So, the conclusion is very, very important. So, it is a factor of this polynomial. First one is the factor of the second polynomial. Why? Because r of x we got it as 0, means remainder is 0. Okay. Now, shall we do the second one? Second one, again we have x square plus 3x plus 1 and 3x to the power of 4 plus 5x cube minus 7x square plus 2x plus 2. Now, here, see here, 3x to the power of 4 divided by x square. So, when you divide, what remains here? What is the quotient here? 3x square. So, 3x square. Now, the first term will be 3x square. Now, what is the next step? Next step, you have to multiply this polynomial by 3x square. Now, take one term at a time. 3 into x to the power of 4, I am multiplying this. Next, plus 3 3s are 9 x cube, 9x cube, 9x cube. Next, plus into plus, plus 3x square. Now, next step, you have to change the sign. Then, plus and minus. So, greater number sign is minus. Then, now you have to consider this sign, not this sign. So, minus, then 4x cube. You have to find out the difference because of plus and minus 9x square. So, next, both are minus. 7 plus 3, 10x square plus 2x. Now, next term. So, minus 4x cube divided by x square will be minus 4x, minus 4x. So, take minus 4x. Now, this is the second term of the quotient. Now, minus 4x into this polynomial. You have to multiply this polynomial by minus 4x. Now, the first term will be plus into minus, minus 4x cube. Then plus into minus, minus 4 3s are 12x square. Then plus into minus, minus 4x. Again, you need to change the sign. Plus, plus and plus. Gets cancelled. Now here, minus 10x square plus. So, greater number sign you should write. Greater number sign. Then one minus and the other one is plus. So, you have to find out the difference. Next, plus 2x. So, both are plus. 6x. Now the next term, here, see here, 2x square divided by x square, you will get 2. Now the third term is 2. Now 2 into the whole polynomial. So 2 into x square, 2x square. Next, 3 2s are 6. 3 2s are 6x. See this, you have to take it down. So plus 2. Now again change the sign. Now see here, plus and minus cancel. Plus and minus 6x cancels. Plus 2 and minus 2 cancel, giving you 0. Now again here also, in this case also, the second one also, the first polynomial is the factor of the second polynomial. So, the conclusion is very, very important. Therefore, you have to write, therefore, x square plus 3x plus 1 is the factor of 3x to the power of 4 plus 5x cube minus 7x square plus 2x plus 2. This is the conclusion. Conclusion is very, very important. Now, the third one. So, let us move on to the third question. I hope it is clear now. Third one. Okay, now third one. Third one. X cube minus 3x plus 1, x to the power of 5 minus 4x cube plus x square plus 3x plus 1. x cube minus 3x plus 1 and x to the power of 5 minus 4x cube plus x square plus 3x plus 1. Now try to solve this. Now x cube minus 3x plus 1 x to the power of 5, and note here the variable x to the power of 4, that term is not there here. So here can leave a gap, 4x cube plus x square plus 3x plus 1. The next, now just see, the first term is x to the power of 5 and here x cube. So when you divide this, you will get x square. Now the first term will be x square. Now multiply this polynomial by x square. Now x to the power of 5, see, I know how to do this, don't do 3 into 2, you all know. See, according to the law of exponents, see, when you multiply 3 into x to the power of 5, you should be very careful, 2, see, this will be x to the power of 3 plus 2, that is x to the power of 5. Law of exponents, you have studied in the lower class. So this will be x to the power of 5. Then minus x square into x is minus 3x cube. So we won't get x to the power of 4 at all. Okay, next plus x square into 1 is x square. Now again change the sign. Here plus is there, minus, and here minus plus plus. No, cancel. Minus 4x square plus 3x. So greater number sign, 4x cube is x cube. Then here this gets cancelled because plus x square minus x square gets cancelled. Then what remains? 3x, you can take it down, plus 1. Now you see x cube. So again divide minus x cube by x cube. So you will get minus 1. See here, minus 1 remains. Now minus 1. Now from minus, you multiply the whole polynomial by minus 1. So this you will get x cube minus into minus plus 3x plus into minus 1. Now again change the sign, here plus, so get cancelled, plus 3x minus 3 also get cancelled, plus 1, you should be careful, here plus 1 is there, plus 1, so 2. So what is the remainder? Rx is equal to 2. So when Rx is equal to 2 means the remainder is not 0, then we can say that the first polynomial is not the factor of the second polynomial. So you should write the conclusion. Therefore, x cube minus 3x plus 1 is not the factor of x to the power of 5 minus 4x cube plus x square plus 3x plus 1. So only I told you the conclusion is very, very important. I hope it is clear. See, next problem. Actually it is there in your textbook, that is exercise 2.3, third one. Obtain all other zeros. See, the polynomial, they have given one polynomial and they have asked you to find out the zeros. Actually, one example problem, before doing that exercise problem, I will do one example problem. Now, see, this question is a new concept for you now. To find the remaining zeros, please be attentive, to find the remaining zeros when some of the zeros are given. See, for example, the polynomial is of having degree 4, biquadratic polynomial. It is called as biquadratic polynomial. I told you at the beginning in the first class, degree 4 means the number of zeros will be 4. Suppose they have given 2 zeros and they have asked you to find out 2 more zeros for that. So, before doing the exercise problem, I will do one example problem, that is example 9 in your textbook. See, find all the zeros of 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. So, this is the polynomial of degree 4. So, here 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. See, if you know that 2 of the zeros are, so 2 of the zeros they have given, that is root 2 and minus root 2. So, root 2 and minus root 2, this is example 9 in your textbook, example 9. So, here it is a, so how many zeros you expect for this problem? See, 2 zeros are there, 2 more zeros, at the most I told you it will be having 4 zeros. Now, 2 zeros they have given, by using this we have to find out 2 more zeros. I hope it is clear. Now, for that, the first step, now you all know x is equal to root 2, means these are the zeros of this polynomial, 2 zeros of this polynomial, root 2 is there. Now, see here, minus root 2 means x minus root 2, when we transpose it will become like this, and x plus root 2. See, these two are the factors of this. Yes, it is a factor because they are telling these two are the zeros. So, now multiply this now. First step, you have to multiply these two. Now, just observe this carefully. It is in the form of a plus b into a minus b. A plus b into a minus b. So, identity, you have to use the identity. A plus b into a minus b is nothing but a square minus b square. A square minus b square. So, here you will get x square minus root 2 into root 2, root 4. Root 4 is nothing but 2. So, can I write it as minus 2, x square minus 2. Now, what you have to do is, you have to take this polynomial and divide this by this polynomial, that is x square minus 2. Now, divide this, minus 3x cube minus 3x square plus 6x minus 2. I hope you understood. See, take the zeros, these are the 2 zeros, you have to find 2 more zeros. So, what you have to do, x is equal to root 2, x is equal to minus root 2. Now, when you take this x minus root 2 into x plus root 2, these two are the factors of this already. So, factors means again you have divided. Now, you will get, see this is the second step what I am doing. Now, 2x to the power of 4 divided by x square. So, you will get 2x square. Now, 2x square is the first term. So, multiply this polynomial by 2x square. So, you will get 2x to the power of 4, then 2 to the 4, 4x square minus 4x square. So, minus 4x square you can't write here. So, you have to write minus 4x square. Check once again. See, plus into minus, minus 2 to the 4, 4x square minus 4x square. I am writing under the like terms. Again, change the sign. So, this gets cancelled. This as it is you have to take it down, minus 3x cube, and here minus 3x square plus, so greater number sign plus x square, you have to find out the difference, plus 6x. Now, what is the next term? See, minus 3x cube by x square. You will get minus 3x. So the next term is minus 3x. Now multiply this. Here minus 3x cube plus minus into minus plus 3 2s are 6x it will become. See, minus into minus plus 3 2s are 6x. So I am leaving this term now. Now this plus minus, and we are going to cancel these two and this also. What remains? X square. Now what is left here? X square minus 2. X square minus 2. Now here x square minus 2 is there, so definitely it is 1. So x square plus into minus minus 2. Now you will get 0. Change the sign, get 0. Now see, first step you did this, next you have divided. Now you got the quotient, isn't it? That is third step, 2x square minus 3x plus 1. We got the quotient. Now this is the third step. See, in the previous class I had told you how to find out the 0 of the quadratic polynomial. What you will do? Splitting the middle term. By splitting the middle term you will get 2 more zeros. That's it. Okay. Now here 2 ones are 2. Now when you split it you should get plus 2, and when you add you should get minus 3. So 2 ones are 2, minus minus. So minus 2 into minus. So how we can split this? 2x square minus 2x minus x plus 1. Now what is common? 2x is common. So x minus 1 minus is common. See, once again you check. 2x into x, 2x square minus 2x, and here minus x, minus into minus plus, 1 into 1, 1. Now here common is minus x minus 1 and 2x minus 1. Now to get 0 I told you, so this you should equate to 0, and 2x minus 1 will be equal to 0 to get 0. So this part we have done already in the previous class. Now x minus 1 is equal to 0, so x is equal to 1, and in this case 2x minus 1 is equal to 0, so 2x is equal to 1, x is equal to half. Now see the numbers of 0. How many you got? 4 zeros. Which are the 4 zeros? 4 zeros are, therefore the zeros of the polynomial are, yes, this root 2, minus root 2 and 1 and half. See, like this you have to find out. See, root 2 and minus root 2 they had given, and we found another 2 zeros. So this is the method to obtain the zeros when some of the zeros are given. So 2 zeros are given, you will find another 2. That's it. So now we shall do the question which is given in your exercise problem, that is third one. Now third one, obtain all the other zeros of 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. The two zeros what they have given is root 5 by 3 and minus root 5 by 3. It seems very difficult, but it is easy. See, it looks very difficult, that's it. 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5, and root 5 by 3 and minus root 5 by 3 are the zeros. Now, in the previous problem I taught you, so let us take this as x is equal to root 5 by 3, x is equal to minus root 5 by 3. Now, x plus, here x minus root 5 by 3 and x plus root 5 by 3 are the factors. Now, when you multiply this or you use your identity, I told you, a plus b into a minus b. So, this is nothing but a square minus b square. So, a square minus b square here, you will get x minus, see, x square minus this root of 5 by 3 into root of 5 by 3, again you will get 5 by 3. I hope you understood this. Then, so to simplify this, I will use this LCM. So, this can be written as minus 5. See, so if you take LCM also, okay, or just multiply this by 3. So, when you multiply this by 3, so this will be 3x square and this gets cancelled, 3 gets cancelled, minus 5. So that it will be easy for us to divide. So what is the next step? You have to divide. So next step is divide this polynomial by 3x square minus 5. Let me take 3x square minus 5, divide this. 3x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. Now again, you know, 3x to the power of 4 by 3x square will give you x square. Now, first term will be x square. Now, 3x square into x to the power of 4 is 3x to the power of 4. Then minus, plus into minus, minus 5x square, minus 5x square. So, you can't write here, you have to write here minus 5x square. Change the sign and this as it is, bring it down, 6x cube, and here change the sign. So, minus and plus greater number sign, 3x square. Then here minus 10x. Next, 6x cube by 3x square. So, 3 ones are, 3 twos are. So, 2 and here x remains. So, 2x. So, the next term is 2x. 2x. Now, multiply 2x by 3x square minus 5. So, 3 twos are 6x cube plus into minus, minus 5 twos are 10x. So, minus 10x. Now, change the sign. So, this gets cancelled, minus and plus gets cancelled. Here 3x square. 3x square. Now, the last term, that is minus 5. Now, see here, 3x square minus 5 and 3x square minus 5, definitely it is plus 1. Now, 3x square minus 5. Change the sign, 0. Now, what is the third step? So, this is the first step. you have to, the given zeros, you have to use this given zeros and multiply, and from that polynomial you have to divide this. So you will get this quotient x square plus 2x plus 1. This is to find out the other two zeros. Again you got a quadratic polynomial. Now again the splitting the middle term, x square plus, definitely you know here 1 x plus x. So this you know, I hope, 1 into 1, and when you add you will get 2. So 1x plus 1. So here x is common, x plus 1, and 1 is common, x plus 1. So x plus 1 into x plus 1. X plus 1 and x plus 1. Now the zeros, how to find out the zero? I told you, you should apply, you should p of x will become 0, that is x plus 1 into x plus 1 is equal to 0. Therefore x is equal to minus 1, x is equal to minus 1. Now, so you got 2 more zeros. So the zeros are, therefore right here, therefore the zeros of the polynomial are root of 5 by 3 minus root of 5 by 3, then minus 1 minus 1. So these are the 4 zeros of the polynomial. I hope it is clear. Okay, we'll move on to the fourth one. Okay, now we will move on to the fourth one. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and the remainder were x minus 2 and minus 2x plus 4 respectively. You have to find g of x. See, this actually we studied in the previous class, division algorithmic. So I hope you can remember that. That is p of x See, p of x is equal to g of x into q of x plus r of x. You can remember this division algorithm. Now just write what all they have given. On dividing x cube, so here p of x is x cube minus 3x square plus x plus 2 is equal to g of x. So you have to divide by g of x. We don't know g of x, so I have written g of x only. Now next, the quotient and the remainder where? Quotient is x minus 2 and the remainder is plus 4. So you have to apply this here. Now p of x is x cube minus 3x square plus x plus 2 and g of x we don't know, we have to find out. Then q of x they have given x minus 2 and r of x they have given minus 2x plus 4. Now to find out g of x, see here you can make out by transposing g of x will be equal to the whole this p of x divided by x minus 2, then you have to subtract it also from, that is r of x. So now we will just do it. Now we will subtract this one, we will just transpose this. So let g of x, x minus 2 let it be. Now x cube minus 3x square plus x plus 2, when we transpose this minus 2x, this will become plus 2x plus 4 minus 4 is equal to. I hope it is clear. G of x into x minus 2, this minus 2x when you transpose to the other side it will become 2x and plus 4 it will become minus 4. First let us solve this. X cube minus 3x square, here plus x it will become 3x, here minus 4 plus 2. Now this is equal to g of x. Now I want to remove this. So here multiplication g of x into x minus 2. So by transposing this, it will be in the denominator. Means we have to divide this polynomial by x minus 2. Then you will obtain g of x. I hope it is clear. Once again let me explain. P of x is equal to g of x into q of x plus r of x. This is the division algorithmic. Now p of x, we don't know g of x, we have to find out g of x and the rest, the other 3 polynomials they have given. So I have substituted. Then now from this you have to, first we shall transpose this. So when it comes to the other side, this will become plus 2x plus 4 will become minus 4, which is equal to g of x into x minus 2. Now I want to find out g of x. So I will divide the whole polynomial by x minus 2. Now this is a simple division. When we do the division, you will get the value of g of x. Let me do it here now. X minus 2. Again divide x cube minus 3x square plus 3x minus 2. Now here the first term will be x square. X square. I hope you understood this. So x square into x will be x cube minus 2x square. So when you change the sign, this gets cancelled. Your greater number sign is minus. Minus 3 plus 2 x square plus 3x minus 2. Next, here again you divide minus x square by x, you will get minus x. So the next term will be minus x. So plus into minus, minus x square, minus into minus plus 2x. Now change the sign. here gets cancelled, 3x and 2x, you will get x minus 2, greater number sign. Now x minus 2, then here plus 1, x into x, plus into minus, minus 2 ones are 2. Now again change the sign, minus, and this become plus, it's cancelled, so 0. Now what is g of x then? So g of x, see when we divided this polynomial by x minus 2, you will get g of x. So when we divided, we got this answer, that is g of x is x square minus x plus 1. So this is the answer. G of x is equal to x square minus x plus 1. So this is the only one problem they have given in your textbook. Now the last problem. The last problem in your textbook. See this last problem in your textbook, that is give examples of a polynomial, polynomials p of x, g of x, q of x and r of x which satisfy the division algorithmic, and degree of p of x should be equal to degree of q of x, degree of q of x should be equal to degree of r of x, that is second one. First one, let us take it first one. See, give examples for the polynomial. See, actually this answer, there are multiple answers, means n number of solutions you will get. So all the students need not get the same answer. This is somewhat like trial and error method also. Okay. So n number of examples we can give. Now I will give one example. So see here, degree of first one, degree of p of x will be equal to degree of q of x. Now see here, see the condition, two conditions are there here. One is it has to satisfy the division algorithm, that is p of x is equal to g of x into q of x plus r of x. First condition. Second condition is that the degree of p of x should be equal to the degree of q of x. See here, degree of p of x, let us take degree 1. Okay, one example I am giving. So you can try out some other examples also. So degree of p of x is 1. And they are asking you the degree of, that is the condition, degree of q of x also should be 1. Yes, that is the condition. Two conditions. One is it has to satisfy this division algorithm. Second one, the degree of p of x is equal to the degree of q of x. Yes, is it clear? Okay. Now, see, just tell me. Now, whenever you want to multiply these two, see for example, just now I told you, see g of x, if suppose if it is x square and q of x if it is x, means because we are taking degree 1 means x to the power of 1 degree 1. Now, whenever we multiply this, this will become x cube. I hope you know this. Just now I told you, using the law of exponents, this is x to the power of 2, x to the power of 1, 2 plus 1 is 3. Okay. Now, see, when you multiply these two, you will get the degree 3. But what is the condition? The degree of p of x should be 1 only. So, definitely we can't take this as degree 2 also. Then what else we have to take? Then it is a constant only. It should be a constant term. Means the degree should be 0. The degree should be 0. Then only we can get degree 1 here. Then definitely here r of x, you all know the condition g of x. When you compare g of x and r of x will be less than g of x. So here definitely less than means less than the constant means degree 0. It can't be minus 1, you all know. So again here also it is constant. I hope it is clear. Let me explain once again. See, p of x, if we take degree 1, q of x also it should be degree 1 only. If you take 2, degree 2, then this also should be degree 2 only. So if you want these two of equal degrees, then we can't multiply it by any of the other degree except constant. Then definitely r of x should be less than the degree of g of x. The degree of r of x should be less than, or r of x should be equal to 0, or it should be less than the degree of g of x. So definitely if this is a constant, even this is also a constant. So now I'll give one example of this. So this is the first one. One example. Let me take this p of x as 2x square plus 2x plus 14. Then g of x, let me take a constant because here I told you constant. Now here q of x, we can take it as x square plus x plus 7. Then you can find out the remainder. I hope it is understood. You can find out r of x. Now see here, when you divide this, okay, you need not take this also. See, I told you the condition. So it is q of x. Q of x. So now you don't know. See, any example you can take. I have taken this example 2x square plus 2x plus 14, and I have to divide by constant only. Then here I will get, again I should get the degree 2 only here. See, I will divide this. Now this is easy to divide. So when you divide each term by 2, so here only I will divide. When you divide each term by 2 by the constant, then you will get x square plus, see, each term means you have to divide this term by 2, again you have to divide this term by 2, this term by 2, or you can apply this method also, 2, like this also you can do, like this also you can do, but since it is a simple one, I am doing it here only. See, 2x plus 7, see, I got this quotient as x square plus x plus 7. Now the remainder, actually what is the remainder? Remainder, because since it is divided, it is divisible, the remainder will be 0. This will be 0. Now the answer p of x what we took? This 2x square plus 2x plus 14. Then what is g of x? G of x we took constant, that is 2. Then what is q of x? Q of x we got it as x square plus x plus 7. Then r of x we got it as 0. See, now the condition is p of x is equal to q of x. I mean the degree of p of x is 2 and q of x is also 2. So that is the condition, and definitely if you apply here it will satisfy the division algorithm. Yes, okay. Now second one, I will move on to the second one. Again I told you, you can get a different answers. You need not get the answer which I have got. You can take a different examples. N number of examples you will get. So the next one is degree of q of x is equal to degree of q of x is equal to degree of r of x. Degree of q of x is equal to degree of r of x. Now this is the condition, and also it has to satisfy p of x is equal to g of x into q of x plus r of x. Now here just observe q of x and r of x, the degree should be equal. The degree should be equal. Now if suppose if I take this, for example here I will take degree 1 for this degree 1 and this degree 2. Okay, just observe, in the previous sum I told you. See, if this is degree 2 and this is degree 1, definitely this will be of degree 3. I hope why you understood. See, 2 into 3 means 2 plus 1 degree we have to add. So definitely this will be 3. Now r of x also you will get degree 2 only, because they are asking you degree 1, because q of x and r of x should be 1 only. Now one example we will take. See, let us take this as degree 3 means x cube plus x square plus x plus 1 is equal to, let us take g of x as of degree 2, that is x square minus 1. Now we can find out q of x and plus r of x. We can find out by dividing this. Now see here, x cube plus x square plus x plus 1, divide this by x square minus 1. Now the first term will be x into x cube minus x. So here minus x, and change the sign. Now what is this? X square, and this gets cancelled. Sorry, no, this is plus x, 2x plus 1. This does not get cancelled, x and x. So plus x, 2x plus 1. Now the next one I need to get x squared, that is plus 1. So plus into minus, minus 1. Change the sign, this gets cancelled, plus 2x, have to change the sign, plus 2. Okay, now, yes, now you got q of x as x plus 1 and r of x as 2x plus 2. Now what is the condition? See here, q of x, degree of q of x should be equal to the degree of r of x. Degree of q of x is 1 here, degree of r of x is also 1. So that is the condition, and also it satisfied this division algorithm. Yes. So this is somewhat like trial and error method. So you have to do it. And the last one, degree of r of x is equal to 0. So many example we did, that is in the previous sum, that is in second main